Well, welcome to class again. Let's sum up with where we're at. We have about a month left in lecture, and so far we've been able to really cover the front end in depth. We've been able to cover the back end server in depth. We've done a lot of work inside of the browser environment. We've done a decent amount of work now with a web server using Node as our runtime environment, using Express as our web framework so we can scaffold out our web applications. We've done some labs that allows us to design around REST endpoints and build out a REST API. And in addition to that, create a web client that consumes those endpoints to actually build a multiplayer version of the high-low game. So at this point, we should be relatively familiar with the front end portion of a full stack application and the back end portion of a full stack application in terms of the server aspect. So the last component we really need to introduce for a full stack application would be the database layer or data store, where we can go ahead and maintain our data. And so we'll probably spend a couple of lectures talking about just the role of the database, and in particular, in this lecture, we will be discussing Mongo. However, if you've already taken the database class and you're familiar with using another database like Postgres or whatnot, you're free to do that. But I figured I would vary it up from the other course that you might take. So we'll be looking at using a document-based database as opposed to a typical SQL style database. Now, I will say, when I organized the lecture for Mongo, I was heavily inspired by Mongo's actual courses. So one thing that I should make you aware of is that MongoDB, the actual developers of this technology, has their own university domain where they offer a number of different courses where you can get certifications from, and they're all free. So here you can see they have one that focuses on MongoDB basics. They have MongoDB if you already know SQL, basic cluster administration, aggregation framework. Let's see here, MongoDB for either Java developers or JavaScript developers. And any one of these, you can go ahead, enroll, and learn how to use Mongo from the people who develop it and get a certification afterwards. So I'm going to target my lecture towards their Mongo Basics credentialing, and the lab that will be associated with this lecture will be for you to actually go through their coursework and receive the certificate. In fact, the submission for that lab will be to turn in their the URL that they provide to you to illustrate that you've got certified in using Mongo. And so that way you could update your resume, you could update your portfolio page, you can update your LinkedIn account with this certification that actually comes from the maintainers of this technology, which is always really good to illustrate that you know how to use the technology, is to have a certificate from those who have developed it. Anyway, with that said, let's move on to our slides for today. Okay, so we will now be discussing MongoDB. This is going to be cover the basics. So it's going to be pretty much presented across 6 different chapters. And again, this chapter breakdown will be very much akin to the official documentation and education materials provided by Mongo. So effectively, we'll talk about what is MongoDB, how can we import, export, or query data from a MongoDB database, how can we create and manipulate data from a MongoDB database, how can we go ahead and perform some advanced CRUD operations. We will do some indexing and aggregation pipeline, and then talk about the next steps moving from just learning these basics. Outstanding. So let's go to part one. What is MongoDB? And of course, we'll break this down into some sub-modules. We will define what is MongoDB, the database, what is a document in MongoDB, what is the MongoDB Atlas, what is the Mongo Shell, and then we'll look at some basic shell commands. Okay, so first let's talk about collections. Collection is essentially an organized store of documents in MongoDB, usually with common fields between documents. There can be many collections per database and many documents per collection. So effectively, a collection holds multiple documents. A document is pretty much a JavaScript object. So one thing to know about MongoDB database is that it is NoSQL. And so if you had taken a database class, or if you have taken a database class, or when you take the database class, you're going to learn how to use a structured query language to go ahead and access data, to query data from your database. And so it's important to understand that the data is not stored in a MongoDB the way it would be in, say, a Oracle database or a typical table-like database. So it isn't to say it isn't organized, though. MongoDB is a database, and it is a structured way to store data and access it. But what it means to be NoSQL is that it just means that it doesn't use a related set of tables to organize your data. So it's not necessarily defined as rows and columns, as essentially a 2D array. So there are other examples of NoSQL storage mechanisms. A common one that you might have already learned is the way that library card catalogs organize books, right? That is a non-tabular way of organizing data. I don't know if how often you go to a library and still use the Dewey Decimal System. However, to a more sophisticated and modern approach would be MongoDB. And so really that all this, the intention here is that the organization would be more about a document database. So we're going to be able to search or query based off of this notion of documents as opposed to this notion of tables. And so that means that MongoDB is really stored as documents and not tables. These documents are in turn stored in what we call collections of documents. And again, all you want to think of a document as is as a JavaScript object. For all effects and purposes, that's what it is. Okay, so what is the MongoDB database, and why is it a NoSQL database? Because it uses a structured way to store and access data. However, that approach does not utilize tables, rows, and columns. It uses documents, fields, and values. And so let's define those terms. A document is a way to organize and store data as a set of field value pairs. Again, when you hear document, think of objects in JavaScript. A field is a unique identifier for a data point. When you hear the term field, think of key, right? So instead of key value pair, the term that's used is field value pair, but effectively it is the same thing. Field is analogous to key in this instance. A value is some data related to a given identifier, and a collection is an organized store of documents in MongoDB, usually with common fields between documents. There can be many collections per database and many documents per collection. Okay, so what is the MongoDB database? Well, we know that a MongoDB database is an organized way to store and access data. We know that the MongoDB is a NoSQL database that uses documents to store data in an organized way. And what it means not to be SQL means that it does not organize documents in rows and columns. And the database does not use tables of related data. Okay, in MongoDB, how many How does a document relate to a collection? Well, a collection consists of one or many documents. So you want to think, you can almost think of a collection as being like an array of objects. In a MongoDB document, what is the role of the fields and values? Field is a unique identifier for a specific data point, and each field has an associated value with it. So you can't have isolated values on their own. Every value has to be associated with a field, or essentially a key. And then what is MongoDB Atlas? Okay, so we fundamentally just talked about what MongoDB is. It's just a way of being able to store our JavaScript objects in terms of documents. Collection of those documents is called, well, collection. MongoDB Atlas is a fully managed cloud database, which is developed by the same people that had built MongoDB, and it handles all the complexity of deploying, managing your database deployments. So effectively, when you go to deploy your web application, you can have a front-end component like your HTML and your CSS and your JavaScript, and that can all be hosted on a server somewhere. And it does not have to be the same server that you host your back-end RESTful API. So say, for instance, a part of your full-stack application could be deployed on GitHub pages, the static portion, the front-end portion. Then you could run some back-end portion that has a dynamic server that listens to a variety of HTTP requests, like put requests or delete requests or GET requests that aren't just serving static pages, or post requests. And so you might deploy that service onto Heroku, for instance, that actually supports a dynamic server. Then if you need it on your data persistence and some data store that your server can access to go ahead and save the data for various requests and responses, then you would have a third instance that's deployed somewhere that will house your data. Now, data obviously consumes space, and so your default Heroku instance isn't really set up to manage data outside of like whatever is in memory. So if you want data persistence, you'd have to find some data store. Now, I do know Heroku offers one data store. It's Postgres. I will be covering Mongo for this lecture, and in that instance, it would behoove you to go to the MongoDB Atlas, as they have a free tier or service that allows you to manage a Mongo instance, a Mongo cluster that you can use for your projects. And so that's what Mongo Atlas is going to provide to us. Essentially, they have a free tier service where you can deploy a Mongo database and access it from your backend server. Okay, so you can use this. So with Mongo Atlas, you can use MongoDB Database for data storage and retrieval, and MongoDB Atlas is a hosting service for your MongoDB database instance. Okay, so effectively, it's a cloud-based database with a cloud-based database architecture, which is what MongoDB Atlas would represent. There's a couple of key concepts as to what the key features are going to be that we're going to provide to you. So there's this concept of a replica set, and a replica set is just a few connected machines that store the same data to ensure that if something happens to one of the machines, the data will remain intact. It comes obviously from the word replicate, or to copy something. And so typically when you go to deploy some kind of Mongo database, what they do is they call it a cluster. And what a cluster is it's a group of servers that can store your data. And the idea behind a cluster is that you can then define a replica set. I want to say the free tier of Mongo has a 3-machine cluster, which means that your data is duplicated across 3 different machines. So if at any one time one of them fails, you essentially maintain a backup on the other 2. So the likelihood of losing data in a database that's cloud managed is very little, which is one advantage about going for services like this. And then an instance, when we define the word instance in this case, just means it's a single machine locally or in the cloud running a certain software like MongoDB. So for instance, you can go ahead and install MongoDB software and run a local instance for testing purposes, just to show that your app works. But that would not work well if you want to deploy your app to go ahead and actually be live on the internet, because you won't be able to use your local machine to host your server. And so we'll, again, seek to use these cloud-based solutions so that we can actually have live demos that you can then publish a URL to, have on your portfolio page, have on your resume, so that you can really show off a full stack application, potentially to help get a job. Okay. And again, this is just an example of what you would get at MongoDB for the free tier. You get 512 megs, and yeah, not much there other that I care about. Okay, so let's talk about how MongoDB Atlas relates to actual MongoDB. Really, they're both MongoDB products. One is the database software, and then the other is a cloud-based solution for you to deploy it. And then Atlas just has many tools and services within it that are built specifically for you to manage your MongoDB database. Okay, alternatively, let's talk about Mongo Shell. The Mongo Shell is an interactive JavaScript interface to MongoDB. You can use the Mongo Shell to query and update data, as well as perform administrative options. The Mongo Shell may be used with any Mongo deployment, not just from Atlas, right? So you can use Mongo Shell to access your local installation of Mongo, or if you find some other cloud-based solution for managing a Mongo database, you could also connect it with that. So essentially, it's just a terminal. I provide a download link right here so that you can use this PowerPoint slide to access and install. I would definitely recommend installing this locally, though. And let's talk about some keywords, some commands that we can use for the Mongo Shell. If you want to connect to an Atlas cluster with the Mongo Shell, you'd use the keyword Mongo once you have the Mongo Shell installed into your environment on your OS. And then you can use this SRV command here. So you'll see right here inside of the string, I will put Mongo plus SRV, which is a secure way of routing towards your database. And then you can go ahead and offer up your username and your password. Clearly, you would not want to put this on any client-side code, as this would give access to your database to be able to create or read or update or destroy or delete things off of it. Anyway, so this is your credential information, and then you can go at then whatever the cluster name that gets generated for you through atlas.mongodb.net/ and then admin will give you access to the admin roles to be able to do whatever you want there. So for the lab component of this, where you actually go through the Mongo University, you can actually install Mongo Shell on your local machine and access it remotely on your local machine using this command. And then once you're connected, you can issue a help command, and you can see all these different options. And I can actually show that. Let's see here. Okay, come on, computer. Okay, so let's see here. So, so here is an example that I have. I have my Mongo instance here that I can connect to, and notice it will initialize this Mongo Shell, and it will connect to the cluster. It will provide a session ID, and now I have access to what's inside of this cluster, inside this database. And then some of the things I can do here, I can issue help, for instance. And here is the same thing that you see here. So these are by default all the commands I could do for the Mongo Shell. Useful ones that I'll key out now, you can type in exit to exit, that quits the Mongo Shell. We'll talk about IT to be able to iterate when you have lots of results. Show databases shows the databases that you're currently connected to. Shows collections will show the collections in a current database. Use right here will go ahead and use, will set your current database to be that database from your various databases that you're connected to. And then you have all these options to be able to show the database names or show the users, show profiles, show logs, and whatnot. Okay, so let's see here. So if I go and do show databases here, we can see part of the, I connected to the cluster for the actual Mongo University course. So this will be something you'll be able to see as well when you start doing this lab. You'll see that there's actually a number of different databases that are a part of their the lab work and the quiz work that they'll go ahead and kind of give you on that. And if I wanted to go ahead and say, for instance, access this sample training database, so notice there's a number of databases here, and there's all sorts of data that's already been populated for you to play around with. Then I could go and say I want to use, and then I could type in sample training. And then here you'll see then it switches to my current database to be pointing towards the sample training. So now if I type in just DB, I will see it dereferences sample training. And then so if I then say, okay, show me, I've seen show databases here, right? Another option I see in this help is to be able to show my collections. So if I do show collections, here it shows me that the collections inside of this particular database. Remember, collections is just a collection of documents. A document is essentially an object. I would have a collections of companies, of grades, of inspections, of posts, of browse strips, and zips. Okay. And then if I want to leave, I can just exit out of there, and it exits me out. I'm back in my bash. So now I can just close out of that. Okay, so that's just a quick, dirty demo, I guess, of what this Mongo shell looks like with some of the basic commands that are worth knowing. Oh yeah, and so here are some slides that kind of highlight those same things I just showed. So ShowDBs shows the is a command that shows all the databases in the connected MongoDB instance, and then use. And then sample training, just like I showed, switches to that. If I type in DB, I can dereference that whatever the current database is. If I request to show collections, it will show me all the collections in that particular database. Excellent. Okay, so I feel like we've gone through an explanation of what is MongoDB, how is it organized, how does it structure our data, what is Mongo Atlas, and what is Mongo Shell. So I think for the most part, that kind of sets up what it is these technologies are. And if it's not clear yet, let me just summarize by saying MongoDB stores the data for our web application for us. And it's the data that we want it to be persistent. It's the data that we need to store like indefinitely. So examples of that might be, for instance, user names or user profile information, or any other data that your app might depend on. Okay, so let's move on to talking about importing, exporting, and querying data from our MongoDB database. Well, we'll break this section down into the following. How does Mongo store the data in the database? Then we'll talk a little bit about what is a JSON versus what is a BSON. We'll talk about importing and exporting from a database. Then we'll talk a little bit about Atlas graphic user interface they call Data Explorer, and then we'll drop back into the Mongo shell and look at the MQL. So I briefly mentioned that typically the way you interface with most structured databases or tabular databases that define an organization based off of row column indexing, that's usually referred to as SQL, structured query language. So the language that we want to classify for accessing our data, for doing our CRUD operations, for being able to create, read, update, or delete things from our database will be called MQL, right? It will be our Mongo query language, which will be essentially similar, but it allows us to issue these commands as essentially as in a JSON format, and be able to do it on documents, or essentially JavaScript objects, as opposed to table data. Anyway, so we'll go ahead and look at MQL for being able to do queries, which means we want to read from the database, which means we want to find particular objects or documents from our collections. So we'll look at find, we'll look at find one, and then we'll talk about some of these supplemental ones, like what count does and what pretty does. Okay, so how does MongoDB store data? Well, MongoDB uses documents to store data. Clearly, we've already mentioned that. But how are documents represented as memory, and what is the correct syntax for these objects that we call documents? Well, when you view or update documents in the Mongo shell, you're essentially working with something that very much looks like JSON, right? And so this is nice for us because we've been looking at JSON-like things all semester, right? And JSON, again, stands for JavaScript Object Notation. So a little key distinctions that I don't think I've formally made, or if I have formally made, it's been interspersed throughout the semester. And maybe one of these days I'll actually just make a dedicated set of slides talking about JSON. But for now, let me label what JSON formatting requires, because JSON format actually is more restrictive than JavaScript, what JavaScript allows for object creation. So we always have to start and end our JSON with curly braces. That is a must. We have to separate each key and value pair with a colon. Okay, so far so good. So far, both these things are pretty similar to how it operates in JavaScript. We separate each key value pair with a comma. Yeah, this is also true for the way that we define literal objects in JavaScript. All keys are surrounded by quotation marks. Okay, so this is where there's a distinction between JavaScript and JSON. There is a requirement in JSON that the keys are always surrounded by quotation marks. Now, these quotation marks can be implicitly added in our JavaScript runtime environment, but you cannot expect that when you essentially serialize this in a JSON file. And the reason why is because JSON files are used by applications that are not just JavaScript. Say, for instance, you could use JSON files for a Java application to define configuration information. And so in order for Java to be able to parse that, it always defines strings using the double quotation. So you can't use single quotations either. You cannot use the apostrophe character. So whereas you have that flexibility of using ticks or apostrophes or quotation symbols to define a piece of text in JavaScript, you have to use the double quotation, the quotation mark inside of JSON for it to be valid. And then all string values must also use the quotation marks for that very reason. So your values, your field values, don't always have to be in quotations. If it is primitive data like true or numerical data, it doesn't have to be demarked as with a quotation. But if it's anything that's text-based, you have to obviously label that as a string, and you're only giving the one symbol of quotation. Okay, I'm going to stop saying the same thing multiple times. I promise. Okay, the last thing I want to mention for the JSON format is that the keys are called fields. So this is in particular for Mongo, though, not necessarily JSON in general. JSON in general, we can refer to that as a key value pair. But in Mongo in particular, every time you see in the documentation their reference to fields, you can consider that as also meaning a key. Okay, so let's look at some examples of valid and invalid JSON, just so that we're 100% sure on this. This is valid. Notice we open and close with these curly braces. We have commas that follow each key value pair. Each key value is separated with colons. Each key has the double quotation. Each value also uses double quotation when it is text-based. Notice for primitive data, like numbers, it does not require for double quotations. But again, anything like this state here, which represents a string of text, requires that. We can even have, if we look in here, and I think I'll show this more on the next page, objects that are nested inside of other objects, what we call, now recall, this looks very much like an object. It's also JSON. In Mongo, this thing that we're looking at right now is what's called a document. So every time I say document, you can also think object. You can also think JSON. So this is a document in Mongo. Okay, this is an invalid example. First of all, it's using square brackets instead of curly braces. The keys do not have quotation marks around it, so that makes this invalid as well. So really, that's the biggest distinction between what's on the left-hand side and the right-hand side. Okay, so I do want to highlight this concept that documents or objects can have as one of their fields some other document or object, and we can consider this a subdocument. So in this example, this document has a field called address, and the value of that field is a document or a key value pair itself, which might have a city, a zip, a street, and a number. Okay. So let's talk about some pros and cons of JSON. Pros is that they're extraordinarily friendly to work with, right? We're very used to them. We've used them on client side. We've used them on in either client side or server side in our JavaScript runtime environment. It essentially represents a JavaScript object. That's what the actual name is defined after. So these are extraordinarily friendly, especially for us as JavaScript developers. They're super humanly readable. In fact, it's one of the most readable, in my opinion, one of the most readable ways of defining a configuration file. So again, we use JSON files to define the configuration of our web applications through npm using the package.json file. So super readable, and they're very familiar to us. But these pros all come with a con. Well, because they're friendly, one reason why they're friendly is they're text-based, but anything that's text-based is very slow to parse. And so that when you're talking about managing a database, where one of the incentives behind a database is managing over data, inputting data, extracting data, reading data, creating data, persisting data, you want to be able to do that relatively quickly, right? You don't want to have a lot of latency on that. And if your data is always being parsed as text, well, that has overhead, that has latency, we might not be so comfortable with. Another problem with anything that is readable, right? Anything that is all text-based, well, it's incredibly space-consuming. Look at this. This is beautiful to look at, but look at all these spaces and new line characters and everything that's appended to this to make it so readable. And so that's not incredibly space efficient, which is, again, a huge consideration for us when we're talking about database management, where we want to maybe be able to maintain a large collection of data. Then we want to try to compress it to be as small as possible so we can fit as much as possible, especially based on our constraints. If you consider what Atlas gives you in the free tier, you're only allowed 512 megs. So you want to make the most of that. And then the last and final limitation we have with JSON is there's limited data types. Okay, so because of this, Mongo addressed these drawbacks by introducing this concept of BSONs. And what is a BSON? It essentially stands for a binary JSON. Here is a quick depiction of what a BSON would look like if I were to just go ahead and pull it from memory. So the JSON data is stored into memory with a binary encoded optimization. So this bridges the binary representation and our JSON format. And of course, BSONs are optimized for speed and space and flexibility, essentially all the cons that we identified from the previous slide. And this is what will allow us high performance in our Mongo databases. And it's really designed with a general purpose focus in mind, not just a specific domain. And so if I were to compare this concept of JSONs to BSONs, I can compare the encoding. So again, this is text-based, so it's going to be UTF-8 string, where this is a binary encoding. So we'll get a much better compression because of this alteration in encoding. In terms of data support, we were limited to strings, booleans, numbers, and arrays in JSON, which I think we saw examples of all those in the example when I showed you. Whereas for BSONs, we could do strings or numbers or booleans, or even we can even articulate the type of number, whether it's supposed to be an integer or a long or a float or whatever. We also get arrays and date or even raw binary data, which might be specific to a particular application, which is why what is stated here is that this has a more general purpose focus, is that we do go ahead and allow for this raw binary encoding for the data support. And then the one downfall when we go to compare BSONs to JSON is that JSONs are readable, right, to both humans and machines because the machine can parse it. However, BSONs, once we've converted to BSONs, then it's only really readable by machine, right? Like when I look at this isn't incredibly readable to me. And so really what the metaphor you want to have when working with a MongoDB store with your data is that in memory, it's going to treat everything as BSONs, but the way that we model what's going inside of the MongoDB database is conceptually as a JSON. And every time we want to view it, every time we want to update it, every time we want to delete or read or do anything with it, we can consider it as if it were natively a JSON, but in memory, it's a BSON. Okay, so let's do a quick little quiz then. Which of the following documents is correct JSON? Is it, I should have put like A, B, or C here. Is it this one? Is it A? Is it B? Or is it C? And so let me do some analysis here. Let's start from the bottom up. Yeah, so A is going to be it. It's because if we look, we have the curly braces on each end. We have all the keys are specified with the double quotations. We have colons between, I say keys, fields as well. So the keys or fields are in double quotations. We have a colon between the key and the value. The values that are text also use double quotations. We have a comma between each key value pair. Yeah, this is correct. This does not have curly braces, but everything else would be valid, but the curly braces makes this invalid. And on this third option, we don't have double quotations on our keys or our fields. So out of these choices, yes, A would be the correct one that represents valid JSON, and these other two would be invalid. Okay, so let's look at this. MongoDB stores data in, and so now the question is it BSON or JSON? So MongoDB stores data in JSON or BSON, and you can then view it in JSON or BSON. So I'm going to say that MongoDB stores data in BSON, and you can then view it in JSON, right? Okay, and out of the two, which is faster to parse and lighter to store? Well, BSONs are faster to parse and lighter to store than JSONs. And then here, blank supports fewer data types than blank. Well, if it's between JSONs and BSONs, JSONs support fewer data types than BSONs. And yep, JSONs, BSONs, BSON, JSON, BSON, JSON. Okay, let's move on to, now that we've discussed how in memory we're actually storing our data and how we consider imputing the data, or like how we format the data for importing and exporting from or into our database. Let's actually talk about importing and exporting data. So Atlas, and we're going to be concerned about Atlas because it's likely going to be the platform you're going to use for your projects. Atlas allows for data to import and export from a cluster to different systems, which is super critical because your actual server is probably going to be hosted on Heroku or some other cloud platform. And so data may be imported or exported either in JSON or BSON formats. That's the beautiful thing about the MQL, the Mongo commands, is that we can either have data that is moved from one database to another, in which case you don't have to translate between the BSON to a JSON, or if you're operating with it already in JSON, it can convert it to a BSON for you. So if you want to import or export in JSON formats, you would use Mongo import and Mongo export. If you wanted to import or export as a BSON, so essentially the binary JSON, then you would use the keywords Mongo restore or Mongo dump. And Mongo dump would be the equivalent of an export action. Mongo restore would be the equivalent of an import action. You can see that there are connotations here with the BSONs, and you could think that these connotations are really about being able to store the data so that it can be saved somewhere else, right? The idea of restoring or dumping your database, which is why you would not want to convert to JSON. Whereas this idea of extracting the actual JavaScript object notation information is something that's more akin to how you would import or export into an application. Okay, so just some quick examples of how this would actually look from like the command line, or with either the Mongo shell or if you have hooks into like an Express application or whatnot. The way that this would work, Mongo dump, and then you would specify some URIs, which we've already talked about what URIs are, and then this would be the URI to your Atlas cluster. And then if I want to export that data in JSON, it looks almost exactly the same. I have additional flags where I can specify a particular collection that I want to export. And then on here, if I'm exporting as JSON, I can even specify a flag such that I can export it as a file and actually take this data and create an individual JSON off of that. If I want to import data in binary JSON format, then obviously it looks very similar to what I'm doing here in this export. And then if I want to do it as a JSON here, again, very similar. Okay. So which of the following commands will add a collection that is stored in, let's say we have an animals.json to an Atlas cluster. So suppose we have this JSON animals.cluster, and I wanted to go ahead and add that collection to my Atlas cluster. Would I use A, B, C, or D? Let me change the format of this. So the first thing that should be a clue here is that the file name is JSON and not BSON, right? So right off the bat, that's going to be not a Mongo restore and Mongo dump. These are two things that I would use if I wanted to manipulate binary JavaScript object notation or binary JSON files. So that means that limits me to either being an export or an import operation, a Mongo import and Mongo export. So which of the following commands will add a collection that is stored in animals.json to an Atlas cluster? Well, if I want to add to my cluster, then I would perform an import. If I want to export or pull something from my cluster, then that would be an export operation. So the appropriate answer I'm looking for here would be the action would be Mongo import. Okay, let's pivot over a little bit to talking about how we can actually manage our data remotely inside of Atlas. So Atlas provides a data explorer. It's essentially a graphic user interface that you can manage your database from, which can be super convenient. But obviously, you'll also want to get very familiar with the MQL commands, because you want to be issuing a lot of these commands from your backend web server as well. But for now, let's kind of break down what this interface, what's happening in this interface. So there are many ways to query a collection in your Mongo database. One way is to directly do that from Atlas using the Data Explorer, which is GUI based. So this is good just for testing purposes. And so when you log into Atlas, and if you go ahead and have these options up here to be able to find something from your database, or check the indexes into something in your database, or look at these aggregation pipelines in your database. Right now, we'll just focus on being able to query your database for documents. So you'd want to be selected on the Find view if you want to find data. On this left-hand bar would be the collections, or the databases that are inside your cluster. So for instance, you can go ahead and select the sample training collection. And then here, you can actually type in what your query would be. And your query is, for Mongo in general, queries are defined, formatted as a JSON, which is really nice. We store our data in JSONs, and then we issue our queries to select our data, to find our data as JSONs as well. And then below this this query form would be the results of your query. So these would be, each one of these represents a document or an entry inside of your collections. Now remember that collections are a container of documents. And documents are essentially JSONs or objects, JavaScript objects. Okay, so let's look at some examples of queries. Suppose that you wanted to query the MongoDB collection for all documents where the state is New York. Okay, well, we would format our query as a JSON. So it's going to be a key value pair or a fields value pair. So again, we'll have to format it appropriately. We'll have the curly braces. We will have our keys in quotations. And in this instance, the field that we're searching for, that we want a particular value for, has to be something that exists. Well, it doesn't have to exist, but if you want a result, you will need a field of state inside of each of your document in order to get a result from that. And in this instance, it will query for every state that has the value of New York. We can even define more complex queries using commas to separate multiple fields that we're looking to evaluate. So for example, we could have a query that actually not only checks the state to see if for all documents where the state is New York, but also where the city is Albany. Okay, so if I wanted to query my database inside of Data Explorer, I could type this here and just hit enter. Yeah, that works fine. But presumably, we also want to be able to do this using MQL. And one way to test out our MQL is to use the Mongo Shell. So now that we've queried some data from the, or we've seen how to query data directly from Atlas, let's talk about how to do it from a remote environment. And so again, I might do examples for these lectures in the Mongo Shell, and I implore that you also install Mongo Shell so that you can get direct access. But there are other ways that you can issue these commands, right? Yeah. Now, one nice thing about Mongo Shell is that it does allow you to interact with your MongoDB instance without using a GUI, and it also includes a full functioning JavaScript interpreter. Okay, so the same way that we can issue that query in the Data Explorer, that graphic user interface, the way we would do that as a command would be the find method. And so the find method will return a cursor with documents that match a given query. And so the parameter to find will be essentially an object, a JSON formatted object that has your key or field and a value. So essentially the general syntax of this, and so let me do this to make it more clear. You would do DB, which is your selected database. I showed you that previously. And then you would do DB dot, and then whatever the collection name is that you want to go ahead and try to find something from. And then you would do dot find, and this is a method. And then the parameter to that method is your query object. And so let's test this out. Come on, computer. Okay, so let's go and connect to our database again. Okay. Okay, and now let me show DBs. Okay, so let me use, let's do that sample training. So sample training. Okay, so I switch to sample training. So now if I type in DB, yep, it's on sample training. So now show me the collections. Okay, so one of these collections is zips. So let's actually go ahead and do that query. So let's do db dot zips dot find. And inside of this find here, I'm going to create an object that is going to be to find any document that for the field of state contains the value of New York. And wow, that is there we go. That is we found them there. And here, let me pull this out. Okay, there we go. And so we could see that each one of these instances that I'm looking at, it has an ID field, underscore ID. We'll talk more about that in just a moment when we're talking about inserting things into our database. We see that there's a city field. We see that there's a location field. The location field has a subdocument that has a Y and X coordinate. It looks like there's a pop field. There's a state field, and there is a okay, there is a capital field for some of these, but not all of them. So this illustrates that how in Mongo it's not necessarily it's not necessarily tabular data. I can have more fields in some objects than others. Okay. And notice I have more results than I display. I display like 20 results at a time. So I get this ability where if I wanted to, I could type in IT to get more results. So IT, short for iterate, and it gives me the next 20, and the next 20, and the next 20. Okay, perfect. Now suppose I wanted to use those two attributes, right? I could do db.zips.find. And let's inside of there say, okay, for each state field, find the document that contains New York. But in addition to that, inside that same object, query object, I'm going to do a comma to issue another key value pair to also say for the city field, let's look for the city but when it is Albany. There we go. And in this instance, there's only 7 hits. So no need to iterate through since I can view them all at once. Excellent. Okay. Okay, so just a quick overview of this again. Let me go here, let me go here. Okay. So again, it is a Mongo command that iterates through a cursor. And just to give you some definition of what these words are, a cursor is a pointer to a results set of a query, and a pointer is just a direct address of the memory location. So this just allows us to go and be able to iterate to where in our query set we can look at for inspection. Okay, there's also, in addition to find, notice find allows us to find many things, right? So there's also the ability to find one. Find one will return the first document to meet your query requirements. And so let's test this out really quick. So we saw here, let's change this from find that returns multiple documents to just find one. And notice when we do find one, it not only goes ahead and returns that first instance, right? But it also makes it nice and pretty. So by default, find one will only return one document. And it's nice. This is a nice thing to do if you're not familiar with the fields and you want to issue a query on the fields, to be able to pull one piece of data from your database so you can inspect what fields are there so you can craft your query. So it's kind of useful in that regard if you're not totally familiar with the schema of your objects, especially in Mongo, since your documents could potentially have any number of fields for each document, which pulling the first one might not help with in that regard, which is why it is nice to assign some kind of schema to your document. But not just that, if I wanted to get this same kind of pretty view on all of my documents, right? Like if I get from find, actually I can issue this method called pretty on the results of this query, and it will format all of the results from a find many option to look just like my find one. That makes it incredibly readable. So I can inspect them. Instead of looking like this as one single line, I can see them formatted. And so this could be really meaningful for subdocuments, like for this X and Y, or when you start getting nested or very complex or very big documents that you need to peruse through. You can also do an empty query as well. Empty query will just return all the contents of your database. You also have the ability for a count method. The count method, the find method may return many documents. You may chain a count method after it. It returns the number of documents that the match from your query had performed. So instead of pretty there, let me do this find. So I'm doing this find, which returns multiple things. I can then do count on top of that, and it will count how many things are returned from this query. So this tells me it was 7. And let's see how many things were returned from just my query on New York. Okay. 1,596. So again, I have these helper methods that when I'm finding many elements can either count them for me so I know the number, or makes them pretty to view. Now, let me compare that with find one. Find one here, I cannot notice count is not supported by that. It's only supported by find. I get a error command if I try to do that. Same thing if I try to do that pretty on that. And that's because the default, count is meaningless for find one. It's only going to return 1, so it's not implemented to work on that. And then it already defaults to returning that one document in a pretty format, so that will also fail. So pretty, that pretty method and the count method only work with the find method, not with the find one method. There we go. Pretty. The pretty method returns the document that matches the given query, and it's formatted for easy reading. And we already saw that. Okay, let's move on to creating and manipulating documents. And so when we create a document, we'll talk a little bit more about what's happening with this object ID that we saw earlier. And when we create, another word for creating is inserting. So we insert a document into a collection. So when we talk about create, we'll talk about the object ID, inserting methods, and common errors that can occur when we try to create, and then some options we can do, in particular, the ordered option and what that means for us. And then after we're done talking a little bit about how to create or insert documents into a collection, we'll talk about being able to update documents that are already in the collection, or being able to delete a document from the collection, or delete a collection altogether from a database. And then after that, we would have essentially talked about our CRUD operations. So those are essentially the simple operations that our database has to be able to manage. Okay. Nope, that's not right. Okay, so let's talk a little bit about this object ID. All newly created documents in our collection is populated with an _ID field, and that's what's used by Mongo as its unique key. So we always need an identifier. So Mongo maintains that this _ID field will be the identifier for every document. So every ID in a collection must have that unique value. The rest of the fields and values are not enforced in any way. So what this means to us is you can have a collection where all the documents have the same exact field value pairs in each document, where the only difference between them is the ID field or the _ID field. Likewise, you can have a collection where each document is completely different from one another, where they don't have the same fields, they don't have the same size or shape. And as long as they all have the _ID value, that's okay as well. Now, neither of those approaches are very good for databases, right? Like, what's the point of having a database if all of your documents are the same? Also, it'll be incredibly difficult to manage a database if all of your documents look extraordinarily different. So typically, you want to have documents that look very similar, but have different values. And that's usually the best design of a database. Okay, so let's talk more about this object ID. So let's not. So the object ID is the default value for the _ID field unless otherwise specified. So if we don't give an _ID value to the database, we can give it, but if we don't, Mongo will populate one for us. And so an example of what this would look like is it's going to create this _ID and then this object ID and then this big long object. And Mongo has a formula by which it generates this. We don't really care what that is. We just know that it does that. So if I go back and look at here, yeah, let's look at this. Notice that's the default IDs that have been generated for these documents, is these object IDs here. Okay, so the _ID doesn't have to have the type object ID, though. If you already know of unique values that you can use for your own documents, you can use those values instead of the ones that Mongo would supply for them. And so the only constraint you have to do is when you define an ID that or whatever value you want to have as your ID to your documents, you use the _ID label for that. And then Mongo will preference your ID as opposed to generating one for you. So some examples might be this or this, which notice are not object IDs, but it's fine. It could still be used as an identifier. Okay, so how does the value of _ID get assigned to a document? Well, it is either automatically generated as an object ID type value, or you can select a non-object ID type value when inserting a new document, as long as the value is unique to the document. That's the one constraint, is that those IDs have to be unique. And if they're not, that is what can provide an error. Okay, so insert methods. Insert a new document into a collection. So the syntax for this is going to be DB. Remember, that's our current database that we're using from the Mongo Shell. Then it would be dot, then whatever your collection name is, so the actual collection that you want to insert into, dot insert. And then as parenthesis, as a parameter to insert, you would pass the document, so essentially a object, a JavaScript object or a JSON formatted document that you can then insert into there. So some common errors will be a duplicate key error collection. And this occurs if you try to insert two documents that have the same ID. And so the reason why this is a common error is if you're just copying and pasting from entries, for instance, and trying to enter that way. So let's go ahead here. So insert errors. So MongoDB can store duplicate documents in the same collection as long as their underscore ID values are different, because that's how it's distinguishing them. If a document is inserted without a provided underscore ID value, then the underscore ID field and value will be automatically generated. Yep, we already talked about that. And so here, let's talk about how we can insert multiple documents at one time. We use the same method. So the syntax here is the current DB that we're evaluating, then the collection name we want to insert into, then the same insert method, but instead of just one document, we can do an array syntax, right? Square brackets, and then using a comma separated list, actually provide a number of documents. And again, our documents, when we're doing this, can actually be these, essentially, they would look like these JavaScript objects. Okay. So by default, if you attempt to add two documents with the same underscore ID, an error is thrown because of the duplication. And so all the remaining inserts would then fail to go and be entered into your collection. So for an example, imagine if I had this command. So inside my current DB, my database, I have this inspections collection, and I try to insert into my inspections collection 3 different documents. I have and there's a duplication in the ID for the first and second. They're both 1. That's clearly going to generate an error. But when it generates an error, it will fail to add the documents, even if they're valid, after this error occurs. If I want to ensure that all valid documents can be entered, regardless of whether there's a failure at one point, I can go ahead and pass in an options object that has an ordered field, and it sets ordered to false. So by default, ordered is set to true, which means it tries to insert sequentially. And if there's a failure at any point, it stops. So with ordered, it will continue to go through, even if it does fail, to add everything it can. And so an example of what this would look like would be here after the collection of documents to be added, there's a comma, and then another object, which is your options object, which has this ordered key, and we would set that to false. Okay, so if a collection does not exist yet, so this is an important thing you should know. If a collection does not exist yet, and you are inserting a document into it, then Mongo will create that collection by default. So collections and databases are both created when they're initially used, which means that you can insert a document into a collection that doesn't currently exist, and then suddenly it does exist. That's how you can create a new collection, by inserting a first document into it. And on the flip side of that, if you delete the only document from a collection, then it removes that collection as well. So collections have to have documents in them for them to exist. But this could also lead to a common error where if you accidentally misspell your collection's name, let's say it was inspections, and you just typed in inspection and inserted, it won't create an error there. It would just generate a whole new collection with that one document or the documents that you added with the misspelling on it. So do be wary of that. Okay. And then let's see here, just some questions about being able to insert with order. Which of the following commands will successfully insert 3 new documents into an... What's happened here? Oh, here we go. I feel like my... what is going on here? I don't have my options. Let me hit refresh on here. Okay, that's much better. Okay, so let's look at this. So let's do a quick quiz. Which of the following commands will successfully insert 3 new documents into an empty pets collection? Would it be, and it could be more than one. So does A work? Does B work? Does C work? And does D work? So let's look at A first. We will see that we have our database. We have the pets collection. We will try to insert, and we're going to insert multiple into it. So we will define an array. And so ordered is set to false. So ordered will not work in this instance. So successfully insert 3. Okay. So ordered. So it's not going to do it ordered, which means it will, even if there's a failure, it will continue to try to insert. Remember, failures are only going to occur if your underscore ID is duplicated. So here I have a duplication of ID on the first element of the second element. So normally I would fail. So I'm successful in the first, fail in the second, but since ordered is false, I perform it on the third and fourth elements, which means that I insert 3 new documents effectively and reject 1. So it's true for this first. I do successfully insert 3 there. Let's look at choice B here. The ordered is set to true, which means ordering matters, which means the first time that I have a rejection, I stop. And I have a duplication of IDs after the second, so I'm only going to have a insert 1. So this would not have 3 new documents. Let's look at this third choice here. I don't have ordered set, so by default, ordered is true. The default setting is true, which means if there's at least 1 rejection, I stop there. I have ID 1, 2 is unique, so that passes. 3 is unique, so that passes. 3 ID, that is a duplication, so I reject the fourth, but I still get 3 documents, so that's also true. And then let's see, I have db.pets.insert, and this doesn't have any IDs, right? This is just pet fields with values. So what is going to happen here is Mongo will generate the ID, so all 3 of these will be successful. So this A, B, and D will be successful, C will fail. Oh, wait, no, A, C, and D are going to be successful. B is going to fail. And so that is indeed the case. Okay, let's quickly just look at this as well. MongoDB has a flexible data model, which means that you can have fields that contain documents or arrays as their values. Select any invalid MongoDB documents from the given choices. So which of these, if any, are not valid for MongoDB? And so none of these, all of these are valid, right? So all of those, so the correct answer would be none of the above. Excellent. So the next thing we're going to talk about is updating, but I'm going to save that for next lecture. So we will pick up on this set of slides since we're at 3:15 now, and this is the end of our lecture. We will pick up next lecture with being able to update and delete documents from our collections, and then we will look at the remaining portion of these slides, which will be like advanced CRUD operations and being able to do let's see. Yeah, next time we will finish this chapter, which we still need to do update and delete. Then we will look at advanced CRUD operations and indexing and aggregation pipelines. And then finally, next step. So we should be able to, in my opinion, finish MongoDB stuff either at the end of next lecture or the lecture after next. So it's either going to be 2 or 3 lectures, I would think, of database stuff. But by the time we're done, you should know enough to be able to get a certification in Mongo, which again is what I'm going to assign as the lab stuff. Excellent. Is there any questions for me regarding what we covered already today? Okay, if there's no collections, everyone have a great weekend, and I'll see you again on Tuesday. Otherwise, I'll be on Discord.